Good morning, everyone. Welcome to the Embedded Works with the next webinar. We're going to talk about cool object-based storage and microservers and all sorts of cool stuff with embedded. So we're going to wait here for a few minutes for everyone to join, and we'll get started here in about 2 minutes. So as always, if you have any questions, there's the Q&A section and the chat, which is open to you guys. So give us a minute or two and we'll get started. All right, well, it looks like the attendees have stopped coming in for the moment, so let's go ahead and get started. Welcome to the Works for the Next webinar with Embedded. I'm here with Miss Dominique Sun from Embedded, based out of Taipei, Taiwan. She's going to give us an overview of Embedded's hardware and their unique approach to server hardware. And I'll hand it over now to Dominique. Dominique.
Hi, thank you, Tony. Hello, everyone. So let me start the presentation for today. And thanks for your joining. So the first thing, I just introduced a little bit our company. Embedded Technology, our company, we are a software-defined storage appliance manufacturer and the solution provider since 7 years ago. So today we offer the product, since 7 years ago, we offer the product for the software-defined storage appliance by using our own design ARM-based microserver platform, which could bring a lot of benefit to the distributed storage. And from this year, we also cooperate to support the powered by NX software products like the NX Witness VMS software. So for today, I will share with you how to run the NX server software and the software-defined storage onto the same hardware platform, which is the ARM-based microserver, and which benefit it could bring to you and to the surveillance industry. Okay. So the product and the solution we are talking about right now is the MAS 400 NX. It's an ARM-based microserver running the scalable software-defined storage, which we call it Ceph Storage. You will see it on the following slide. And also this microserver supporting the NX server software. So as you can see, from the past to current, for the storage solution to provide to the NX server, it could have two different ways. The first solution, it could be the traditional way, is running the NX server software and using the direct attached storage for the video recording and capture and playback. And another option, it could be using external network storage, such like NAS. And the benefit by using the external storage, you have more flexible storage, and you might be easier to scale out your storage capacity. So the user, they could have these two different options. However, no matter which option they choose, today, most likely they are using, the current storage approach is using the RAID technology for the VMS software. But the RAID technology, it could not 100% match today's high capacity demand. For example, if you are using the disk array or NAS by using the protection RAID 5 or RAID 6, it has the high potential to fail when you rebuild the high capacity hard drive. For example, you can see in the market, a lot of users, they just use the 4 terabyte, 6 terabyte, and in very rare case, they use 8 terabyte hard drive in their RAID system, because they are worried about the large capacity hard drive. Once any physical fail on the disk, the recovery time will be pretty long, and also they need to suffering the risk during the rebuild procedure. So the bigger hard drive means longer rebuild time, and that also means you are taking more risk to fail. So also during the disk review, I'm not sure if you have this kind of the bothering, but in some customers, they really feel during the disk review, the video recording performance got some interruption or bad functioning. So this is also, you know, the weakness for the RAID technology in current storage market. And the RAID technology, it only could protect your data against the disk fail. But imagine if you are using the direct attached storage with your NX server software together. If the server fail, you will lose bunch of the disk on the same time. So the RAID only could protect your hard drive fail, your disk fail, but it could not protect you against the server failure. The server failed, then you got a lot of the data lost. And also, just like I mentioned, the RAID technology, it could not really allow you to use very large capacity hard drive for your cost reduction or your cost consideration. But however, the cost efficiency is pretty important in the surveillance market and in the data storage. Okay, so also, as I just mentioned, the traditional server is very centralized design. So if you got any problem with the processor or with the memory, you might got a big failure domain, the entire server fail on the same time. So you lose your NX server software, you lose your data storage as well on the same time. So what we could do to solve or to reduce the current storage limitation on the surveillance market. This is what we want to propose to the customer in the market. This is just a short diagram to show you. So for example, we have the IP cameras, and the IP camera is managed by the NX server software. So today, our offering is the user, they could install the NX server software on our Mars 400 NX model. And then we provide a virtual disk. We provide a virtual disk to every NX server as layer backend storage. And this virtual disk, they are supporting by the Ceph Storage cluster. The Ceph Storage cluster is the software-defined storage I was talking about. So in this chart, both the NX software and the Ceph storage, they are both running on the MAS 400 NX. So how to run this? Let me show you our hardware platform, our ARM-based microserver. So this is our MAS 400 NX model. So as you can see on the slide, we have 8 microserver here, the orange block. Every microserver is a little bit smaller than your business card. And every microserver, they have their quad-core CPU with their dedicated 4 GB memory and 8 GB onboard flash, which we have the operating system, software, storage software, VMS software all together onto this system disk. And every microserver, they have 2 times Ethernet. Each Ethernet equal to 2.5 gigabits per second. So for every microserver, they also connect to their dedicated storage. For example, if we say this is the microserver 1, then it has the dedicated hard disk number 1. And also it has the dedicated M.2 SSD. So it has its own storage with the microserver. And every microserver, how do they communicate with the other microserver inside the same chassis or outside the chassis? I mean, in different chassis. So you can see we have 2 switch modules here. Every switch module, it provides 2 times 10 gig for the uplink. So every microserver, as I mentioned, we have 2 Ethernet. So each Ethernet connect to, one Ethernet connect to the switch module 1, one Ethernet connect to the switch module 2. So if you lose any of the switch module for the uplink, it will only impact the bandwidth for the uplink, but the whole server will function normally. So with this spatial microserver architecture, we could just imagine you have 8 independent Linux server in this MAS 400 NX. And every microserver, you can define them as an NX server for the VMS software. Or you could define them for a storage node, which will be used for our Ceph storage. So this flexible and decentralized architecture, which is quite different from the other x86 server in the market. Imagine if today you are using a Dell server or Supermicro server, whatever x86 server, usually they have one motherboard, server motherboard, and many disks, maybe 8 disks, maybe 12 disks, maybe 24 disks connect to the server motherboard. So if you got any fail, then the 8 disk or 12 disk, 24 disk, they will fail on the same time. So this is the centralized design. But we are using a fully different architecture, which is one microserver carry 1 disk. So even today, you got one microserver fail, you only have 1 disk get impact. That's in terms for the software-defined storage. But when you are using the microserver to run the NX server, it has another benefit. Let me show you on the following slide. So before we are talking about to run the NX server software, on the microserver, just let me do a very short conclusion for the storage part, for the software-defined storage. So our solution, we are providing the software-defined storage by using the software protection algorithm, and we don't have the RAID controller. We are not using RAID at all. And as I explained on this architecture, actually, the hardware fail has been counting into the software behavior. So we are designed for no single point of value. So even you fail one small pieces, it won't impact the entire cluster. And we could protect the data against several disks or several servers, or even if you have a pretty big cluster, even for the rack value, it could be protected. And for the protection method, we are using erasure coding to provide the data protection. I will explain on next slide. And just as I say, one microserver control one disk, one hard drive. So we could provide the smallest value domain in the market. And with the software-defined storage, I mean with the Ceph storage, we are running on it. We could have very quick data reheal, or you can say the auto recovery. Actually, our recovery speed is about 4 to 5 times compared to the current RAID system. And the last thing is for the scalability. The Ceph storage is not a storage island. Actually, it's just like you play the Lego, just like the kid play the Lego. If you put more server together, you could scale out the capacity and the throughput and the data performance, data rewrite performance on the same time. So this is the erasure coding, some explanation on the erasure coding. I believe many of you already very familiar with the RAID 5 or RAID 6. So erasure coding is using a little bit similar algorithm as RAID 5 or RAID 6, but it's much more flexible. So we are running an algorithm which called K plus N. So K means how many data chunk you will divide it from your original data. And the K, M means how many coding chunk you want to generate from your original data. So if we do a assumption, if today you have a video file with 4 megabytes, for example, and you do the K plus M equal to 4 plus 2, then that means your original 4 megabyte data, you will divide it into 4 times 1 megabyte object. And then on the same time, our algorithm, it will generate another 2 times 1 megabyte object as the coding chunk. So eventually you have 6 times 1 megabyte object to fully distribute it into the Ceph cluster. But how will this object to store into the cluster? If today we define every object need to go to different chassis, as I show the slide here. You got the 6 object, right? 4 data chunk, 2 coding chunk. Then if I say, if we use the software to define every chunk, every object need to be stored in different chassis. Then when they goes to the data storage, every object will go to different chassis. This is what we define the value domain equal to chassis. But I could also define the value domain equal to disk. Then the value domain will be the disk level. And the list, if your storage cluster is much bigger, you could also define, okay, every data object need to go to different rake. So this gives a very diverse risk assignment for the data protection. It can be fully flexible compared to the current RAID technology. And this will give much high availability to the data storage. So if according to the K plus N equal to 4 plus 2, right now I'm talking about, how many disks could be filled on the same time? The answer is 2 disks. But if you tell the storage, okay, I want all the object goes to different servers, then that means you could have entire 2 servers shut down, but you still keep the data. You won't lose the data. So this gives a much high availability compared to the RAID technology. And this is the reason why a lot of data center, they are using the software-defined storage compared to the legacy storage or traditional storage. And today we want to apply this software-defined storage into the surveillance market. So this is the reason we are running the MAS 400 NX with NX server software together to provide a turnkey solution.
Hey, Dominique, I got a question for you. Who are the original customers that you guys designed this storage solution for?
Our current customer, they are working, okay, the top customer, they are the user who want much flexible capacity demand. That means they could scale out their capacity with the time. Maybe this year is 500 terabyte, next year is 1 petabyte. And who want to use this?
Like, which industry?
Yeah, I will talk about this. First, I just define the requirement. And the industry will be the telecom, the data center, or the big data analysis. Even for the IoT data analysis, they are using our solution. Because all this industry, you know, telecom, they want to use this because a lot of telecom, they are oriented to the software-defined data center. So in their entire architecture infrastructure, they have the software-defined network, software-defined compute, and the software-defined storage. And we have the telecom customer, they are running the OpenStack or Kubernetes by using the Ceph storage as the backend storage. This is for the telecom. For the big data analysis, usually we have customer for the geographic data storage and also for the medical, because you know, for the gene or any X-ray image file, they require a lot of the data storage. They want the storage to be flexible, high availability, and able to scale out whenever they want by an easy way. So this is our current market. So, however, we also have the customer. They are using the software-defined storage in the edge. For example, is for the edge data center who receive all the data aggregate from the IoT sensors. This could be very similar to, you know, the surveillance market, because for example, if today the police department, they want to have all the, you know, just like, for example, the CCTV system in the big city, they might have 200 police office who collect the video data from on the roadside or from the traffic light, or the camera collecting the data, and do the edge analysis in every small police office. And then they share the data together into a central, the central management. And in that case, they might need a flexible, high availability software-defined storage. This is where we find our product could be interesting for the surveillance market. And this is where we start to cooperate with the NX server software. So we could run in both, the VMS software and offering the software-defined storage to the market. Did I answer your question, Tony? Hello?
Yes, thank you.
Okay, so let me continue my slide. Okay, so the previous part is talking about the software-defined storage running on the MAS 400NX. And we are also running the NX server software on our on-base microserver. So what we could contribute different from the other player. The first thing is we could provide a very high density and IP camera inside 1U chassis. Actually, from the microserver I show you in previous slide, every microserver, they could service 30 IP camera on the same time. And these 30 cameras, they could run full HD and 30 frames per second with high resolution without any delay or image loss for the recording, streaming, or playback. It's fully function. We have done the stress test. So if you want to run a lot of the IP camera in a very tiny space server, 1U server, actually one MAS 400 NX, it could support you more than 200 camera on the same time. In fact, it's 240. It's 30 times 8. And also, we all know NX server has the auto failover. So if any NX server fail, the service could migrate to the other servers. But with our microserver architecture, the failover could be achieved very simply. You just add 1 or 2 microserver as spare node, then it could support the auto failover with an extra microservice node. So here you can see this is the, let me show you the video.
Looks like you might have to open it directly in YouTube.
Wait, did you see the video?
No, there was no video playing. It's okay. Maybe open it in YouTube.
Oh, let me, wait. I see, because the Zoom, wait, let me change the share screen to the video. So can you see the video right now?
Yes.
Okay, so this is the our MAS 400 NX. So you can see the blinking one is the microserver, and every microserver. Oh, I got the latency. Wait. And this is the switch module, which provided 10 giga uplink for 4 times. But you could also use the 1 gig switch. And all the disk bay is hot swappable. So this is just a simple video for our MAS 400. So let me go back to the presentation file.
Hey, Dominique, a question came in, which is where are your, where do you guys do your manufacturing?
So let's talk a little bit about
Tony,
since you're all here, well, probably some of you.
Wait 1 minute. Tony, could you repeat because I got some noise?
Yeah, where a question came in, which is where are your Mars 400s manufactured?
Oh, it's in Taiwan.
Okay, thank you.
We manufacture Mars 400 series in Taiwan, Taipei. Okay, so the next one, for the following slide, I will just go through system design practice. So that you might understand more our products, since this is very different from all the others. So imagine we have a project requirement for the 200 camera, and the bit rate required is Full HD and the high quality 30 frames per second. So by using the calculator provided by NX server, we will see the bit rate will around the 5 megabit per second. And if the recording duration per day is 16 hours per day and the days to record the data is 2 months, based on this project requirement, how to decide how many Mars 400 NX to do the service for the project. So with the criteria, we could calculate the total usable terabyte required is 411 terabytes. If we are using the protection method with the erasure coding 4+2, that means we could allow 2 disks to fail at the same time. Then we need the raw capacity around 670 terabytes. So as I told, we are running software-defined storage, so we could use very super big hard drive. So I will use the 16 terabyte hard drive, enterprise grade. And with this calculation, we get a number. We need to have 43 hard disk. So,
Dominique, real quick, are there any sort of drives that you guys recommended using with the device, or can it be any type of drive?
We don't lock different way for the hard disk, so we could use any type of drive. But many of our customers, they are using the enterprise grade hard drive. Remember, I mentioned we providing enterprise storage, so yep. They are using the enterprise grade.
But it doesn't have to be enterprise grade. It could be.
It doesn't have to be. And if you are using the Nearline or the NAS drive, it's still working. But the customer, they need to know the drive. Usually, the consumer drive, it will fail easier than the enterprise grade. But since we are providing a highly protection by the software in the storage, so maybe if customer they have budget consideration, they could choose the cheaper drive. Yeah. At the same time, we also provide the drive certification for certain series. For example, we certify the Seagate drive and the HDF Hitachi drive. So if anyone interested in which drive we are using, we have the list as well. Okay, so I just mentioned we need to have 43 hard disk for 16 terabyte per drive. So how many units for this project? So for the Ceph, we have the data node, which we call the OSD node. So the answer is 43. We just calculate it. And to well manage my software-defined cluster, I need to have 3 monitor drive. 3 monitor node, not drive. You don't need to have drive. And the 200 IP camera, so we need to have 7 microserver node to service the NX server. And we prepare 1 spare node for the NX server failover as well. So with this calculation, we got the answer. It's like we need to have 7 MAS 400NX to run this project. And the total power consumption, exclude the drive, exclude the hard disk, is about 700 watts. This is pretty good for the power consumption. We do a measurement. We could do the same calculation by using, use the DUS and the 2U12-bay x86 server to do the same calculation. So if they also using the 16 terabyte drive, then they need to have full server to support the 43 drive, 43 hard disk. But I need to emphasize one thing, using 16 terabyte hard drive for RAID system is not a good choice, because very few customers, they are doing this. They're always doing 4 terabyte, 6 terabyte, or most I can see is 8 terabyte. I never see they are using the disk array by using the 16 terabyte hard drive. But to do an equivalent comparison, I do 16 calculation here. So every x86 server support 50 cameras. So the total power consumption by conservative measurement is more than 1,600. So it's more than 2 times of our power consumption. So if we check the chart here, we will see, okay, so on the embedded approach, every yellow block is 1 MAS 400NX. So as I mentioned, we have 43 for the hard disk for our software-defined storage. And we have 7 microserver for the NX server software and 1 for spare. Also, we need to have 3 monitor node for our Ceph storage. So the white party, they are the spare microserver. And with the spare, you could preload the hard disk, or you don't need to preload the hard disk. Anyway, this is 2 empty slots you could scale out in the future for the future use. So this is what we could offer with the 7 MAS 400NX. If you check this, you will find, okay, if you got 1 MAS 400 totally out of power or something wrong on it, you just have 1 NX server. You just lose 1 NX server, but this NX server only related to around 30 IT cameras. But if running the traditional architecture here, either if you got 1 server fail, you got 12 disk fail on the same time, and it will cause you dramatic painful on it. And also, you will lose 50 camera on the same time. But I know the NX server, they could migrate the service onto the existing 3 unit. But the data losing on this 1 failed server, which is much more than the embedded approach.
Hey, Dominique, I have a question. Like, how does it compare from a pricing perspective if you had these 2 solutions next to each other?
For the pricing, actually, I don't know the traditional server, how much it will cost to the customer, but we have talked to the, the NX partner, the NX software partner, your distributor in Taiwan. I think they think our pricing is quite reasonable, especially we are offering, a much highly available, high reliability storage. So this might, hello?
So I said, so it should be comparable in pricing, like similar?
It's similar, but I think we are a little bit higher.
Yeah.
It depends on the market. you know, this architecture is not for the 30 camera or 60 camera or 100 camera, but this architecture will be very attractive for the camera more than 300 or 200.
So
Because
as
it also,
the system gets larger, it gets more affordable.
yes, when it's larger, you know, the customer consideration is not only the cost, it also the service and the feature you could provide to them, especially for some critical customer. They don't want the data loss at all. They don't want to lose any their video recording because they are taking the video for quite important things. So the pricing is a little bit higher than if they are using, you know, not using the Dell server. Maybe they are using the Y brand x86 server to run the NX server and to use the direct attach RAID disk array in the same server. So in that case, the installer or the customer, they only counting on the hardware pricing and the pricing for the NX licensing. But our offering also including the software-defined storage. This is the reason why we are a little bit expensive compared to the others, the purely hardware approach. Okay, so let me go to the next one. So just do a summary on our benefit. So we are offering a total solution, including leverage the NX server software and high availability software-defined storage. And this will be very easy for the installer because every microserver already integrate with the NX server software and the software-defined storage. So what they need to do is to define which microserver they want to run the VMS, which microserver they want to run the storage. And both of us has the web-based GUI to allow the user to do the, you know, the segment or configuration. And our solution provide much smaller failure domain compared to our competitors. And you can say it's a no single point of failure storage. And we know NX server software also have the auto failover. So it's no single point for the VMS and for the storage on the same time. And also for the larger player with much more server, they might like the power saving solution because we know energy also costs a lot of money in some country or in some cities. So we could have power saving more than 60% saving in the power cost. And for the space saving, on my practice, on my design practice, we are using 7 unit, 1U. So the space is 7U. And the traditional approach is 2U chassis, 4 units. So it's 8U. But as I say in the beginning, I want to do a equivalent comparison. So I also allow LAN. I also allow the traditional architecture to using the 16 terabyte hard disk. That's the reason why they only need 4 units. But if consider the risk level they could bring to the customer, I think they won't use the 16 terabyte. They will use the maybe 8 terabyte or 6 terabyte. In that case, they need to have much more server compared to us. Okay, this is why I wrote down the 8U++. So all this is the benefit that we could bring to the customers. So in the end, we are running on the microserver. So every microserver, they could configure either for the VMS software, either for the storage server. And storage, our storage cluster, they could provide a storage pool for the backend storage for the NX server service. And all the data, they could protect it by either by replication, either by erasure coding. In the surveillance market, we prefer to use the erasure coding since it's more space efficiency. So when any disk or server fail, our storage cluster will do the auto recovery very quickly. As I say, we are 4 to 5 times faster than the RAID technology. So with our collaboration with NX Server software, we are providing the block device, the virtual disk, to the NX Server as storage backend. Okay, so anyway, if any server fail, any NX server fail, the virtual disk won't be hurt since the virtual disk is provided by the Ceph Storage, not the direct attach of the NX server, which is different from the traditional approach. So in the end, I would like to show you 2 different videos to show our integration with the NX server software. So the first one, let me open it first, since it will jump to the YouTube. Okay, let me go to the first one. So in this video, we are demonstrating, we run the NX server on the ARM-based microserver. And the ARM-based microserver is the ARM 64-bit with 4 GB memory. And we provide 2 virtual disks to NX, all the NX servers. And these 2 virtual disks is supported by the Ceph Storage. You can see it's 2 virtual disks here. But during your installation or configuration, you don't need to run this command line. This is just show you some detailed information. So in this video, we demonstrate that we are providing 2 different virtual disks to the NX server software. And each NX server, it could supporting 30 IP camera without any problem. So one U server, it could host up to 240 IP camera recording. So for the green line and the yellow line is the I/O status on the virtual disk. So as you can see, even to serve the 30 camera per each NX server, the loading for the I/O is still pretty sufficient. So this video just show a full supporting for the all the functionality like our microserver could support the NX server software. So let me show you the second video.
Real quick, when you say that one use server can do 240 cameras, that's 8 microservers running.
That's 8 microserver, yeah. Okay. And you know, since it's supporting by the microserver, so if you have several Mac 400, you don't need to put the NX server on the same unit. You could just do as my practice slide. You could distribute the NX server among all the Mac 400. This will reduce your physical server fail risk as well.
So you could have one embedded device that has all NX microservers and then another one that has all storage. Is that right?
This is 2 different ways. Okay, let me go back to my slide to show you. Just let me go back to the slide. Remember this chart. So can you see the slide right now? Hello?
Yes, we can.
Okay, so you see the blue block, they are the NX server. In fact, you could put all the NX server on one unit, okay, on the same unit. But you could also put them on different unit. This depending on how many Mac 400 NX you have, and if you want to reduce the physical server fail, the risk of physical server fail. So Tony, if I put all the NX server onto one unit, maybe the user, they will worry about if this unit fail, they will lose all the NX server, right?
Correct.
But if I distributed all the NX server onto among all the unit I have. For example, today it's by coincidence I have 7 unit and I have 7 NX servers, so I put 1 on each unit. But if I have 7 NX server, I only have 3 Mac 400 NX. Then maybe I put 2 plus 2 plus 2, or 2 plus 2 plus 3. Maybe I could do so. It's a flexible way. You could do it all in the same chassis, or you could put them onto different chassis.
And there's a related question which came in, which is, does the NX server need a hard drive attached to it, or can it be left without it as a
You don't need a hard drive. You don't need a hard drive for the NX server, because remember, each microserver, we have dedicated system disk is on board flash. And besides that, we have the M.2 SSD for each microserver. So you don't need a hard drive attached to the NX server. The hard drive only need to attach to the OSD node, the data node on the software-defined storage.
Right, okay.
Okay, so the last video I want to show you is talking about our data protection. So let me show you the video. Okay. You see the video right now, right? So in the beginning, it's normal operation. So we are running the NX server and the software-defined storage on the same platform. So we shut down one hard disk in this cluster, okay? Then you can see the web GUI show you, okay, the data The orange part means the data is under auto recovery. So what happened at the same time for the NX server service? As we can see, the green line means the waiting for the IO writing. So you can see the waiting time is very few. It's almost, it doesn't need to wait. So the IO prefer normally is the user, even the NX server software, they could not feel there is something wrong on the data storage. So the data start to self-recover by themselves. You don't need to do anything. You don't need to put the spare hard drive. You don't need to do anything. They will do the auto recovery by themselves. And the service keep going on. And eventually, the auto recovery has been done. Okay, so you see the data come back to all green, and then you got one failed disk drive in this cluster. So as I mentioned, our value is to provide the fully flexible, highly scalable, and the highly available turnkey solution to the customer, including our software-defined storage. So we leverage our software-defined storage and the NX server software to provide a turnkey solution to the surveillance market. This is what we want to share with all of you today. So let me go back to my presentation file. Where is my presentation file? Okay, so actually
Q&A section, it's all right.
Yeah, I just finished all.
So all you guys that are on the presentation today, it's a completely new way of thinking about how to do kind of server hardware, right? And it's really compelling because this is the type of stuff that's used in like Dominique said, in data centers for websites and high integrity data needs. So it's a fundamentally different way of looking at the hardware itself, and it's super interesting. So I'm sure you guys have some questions. Andy said, do you support cache tiering?
For the cache tiering, I think Andy's question is more focused on the software-defined storage, our Ceph storage. So, you know, we support cache tiering, but we don't suggest to use.
All right. Any more?
Yeah, because this is a question more dedicated for the Ceph storage. It's doable, but the cache tiering for the writing is good, but for the reading the data, which is not recommended. That's why I say I don't suggest it.
So cache tiering would be more for like long-term data retention?
Cache tiering, I think Andy's question is mentioned, you know, because we have the SSD pool and the hard drive pool. So the cache tiering is just like using the faster media. I mean, the faster is the SSD as the cache tier for the hard disk pool. Okay. This is nice when you have the data writing in, but it's not recommending for the data reading.
Gotcha. Any additional questions?
And any question?
Anything at all?
Okay.
If not, well, here's the contact information for Embedded. This presentation, Norris, will be up on my.networkoptix.com in the next 24 hours or so. And there will be a link to contact Embedded if you're interested in learning more or in quoting the solution. Any other questions?
Yeah, welcome to write us by email or to call us you can find Embedded website, and anyway, you could check any question with us. We will be glad to answer.
I guess you guys can offer kind of design assistance if somebody's trying to design a system with your solution.
You mean design the system? Yeah, we could consult. There's no problem. Yeah, if anyone want to use our systems and want us to help them to design, we will be too.
Do you guys, here's a question, do you guys do white labeling?
We could do the white labeling, yeah.
Okay. I know there's some Powered by NX partners on the call that might be interested in that, so. All right, we are at 1 hour, so I will let everybody go this morning or evening, or depending on where you are. I know some people, we've got some people online from Australia, from Taiwan, from various places around the world. So Dominique, thank you very much for your introduction to embedded technology.
Thank you everyone for your attention. Yeah, thank you.
Thank you for everybody attending today, and hope you guys had a great, what is it, Thursday? A great Thursday.
Yeah, it's Thursday. And keep safe, everyone. We need to protect ourselves for the COVID-19. Yeah.
Absolutely. All right.
Okay. Stay safe. Bye-bye.
Everyone, have a good day.
Have a good day, everyone. Bye-bye.